Hello world, hello Twitch, hello YouTube. We are live again. So, let me see if everything is okay in the streaming. I will also put some music for us. I actually did some adjustments on the uh, playlist. And I also know that I'm starting later today, but my daughter is sick, and we were deciding if we get her to a hospital or not. We prefer to wait, and let's see if something needed. My wife will ping me. Then I think I will turn the stream off. But for now, everything is okay. So let me play the music. And we are starting. So okay. Yeah. Let me. Oh. Yeah. Uh. First of all, yesterday we saw that our our emulator is running okay. We are already seeing. We are already able to see the screen. So let me. Yeah, let me do something here. I will just stash some test I did. And then we are gonna able to see the Nintendo logo, but for doing that we need to hard code the SCY here. If we do this, we are able to see the Nintendo logo. Bling! But that's wrong because we are hard coding the SCY and X, and that's not what we want, of course. And we saw that this movement of yesterday we also saw that this movement of SCY is too slow, and I suppose that I think that it's caused by this loop here. We are populating, then we are transforming, and then we are updating the thing here. So there are some things to fix here. But I will do a very simple test here before getting any conclusion. What I will do here is checking how much time each loop is taking. Okay, so this is the main loop where we run an instruction. So I will just do this let now. So this instant is Rust standard library for getting. Actually, it's made for measuring time in your code. So we get now here, and then we get like let new now, and then we can do something like simple like this. We get this new now and check duration. Duration since now. So we get the how much time passed since this now and print it. Okay. So this way we're gonna see how much time we are taking to run these instructions. Those instructions. Okay. So let me do something else here as well. Hey, hey, Ptolemy, back again. Do you have any advice tips for daily motivation focus? How do you stay focused on doing this every day and tricks, or is it just natural? So, actually, these make me motivate. That's the tip I can give you. I have a problem actually. I have a problem on doing these kind of side projects. My problem, I think it's like you are describing. I lose my motivation in the middle of the process when I do side project, which is not getting me money or nothing. So then I lose motivation sometime, and then eventually I get it lost. But for this project, I made different. I started streaming. I started uploading these videos to YouTube and doing I mean, exposing myself this way makes me feel me more committed to this. So I think doing this streaming is exactly what I needed to make me continue with my project. So I, for example, today my daughter is kind of sick. I was with her. Um, I talk to my wife. I go there. I just do something, and then I will stop and get back, just because I know that I need to continue because I get this schedule for doing this video to exposing. So I know that there are people waiting for me to doing this. So it's kind of exposing myself, make me to commit with this project. And I think I will continue with after doing this project. I will do other projects and I will do other stuff. And I think I will all the time I will doing this in streaming, uploading the videos to YouTube or something. But mainly because having this as a schedule and having this as a commitment with other people, which are my viewers, and which are you, for example, makes me feel committed to this. So I think this is my tip for you. Of course, there are a lot of other. Yeah, audience definitely helps. I mean, for me, it's what makes me do this every day. And I created this schedule. I do not commit in the weekend because weekend for me it's for my family. But for every business day after the time, work time, I do this. This is kind of a hobby for me, but at the same time, to be committed to that hobby, I expose it. Then the audience gave me this commitment. So that's my way to do this now. So, getting back here, I was just publishing in the Watch People Code in Reddit and also in my Twitter. So, getting back here, now we have a way to measure the time that we are expanding here. So, let's see how much time this part of the code is taking. So if we do cargo run, we start seeing that is nanoseconds or microseconds, and then when we start in doing this part, it takes milliseconds each iteration. And why is that? Because before the LCD flag is enabled, we do not execute this part. So after this flag gets enabled, we execute this part. Before this flag gets enabled, so the CPU run instruction is taking only kind of microseconds or even nanoseconds. But when we get to this part, it's taking microseconds. So let's do something here. I will comment out our implementation, my implementation of the background and viewport, and I will update the screen with the screen itself. So nothing. I will not do any background stuff, any calculation of the pixels and so on that we are doing there. And let's see how much time it takes. Yeah, still microseconds. See here, we can see that micro or even nano sometimes appears there. But so the most important issue we have are in those two lines. So let's do this. I will do only populate background and let's see how much time. So I am not doing the transform buffer into screen, and now it's already in microseconds. So I think this part is taking not too much time, but the most time is on populate background buffer. And so I was checking this, and I think that the problem is right here, because we are populating the background on every iteration. That is already wrong, because we don't need to every CPU instruction. We need to calculate again all the tiles and everything, because we only need to do that when the registers on that area. Let me get back to I think it is here. So only when we have anything changed on the video run, we need to change the background, to populate the background again. Otherwise, it's there. We don't need to touch it. We don't need to calculate that every time. Of course, we need to calculate that every time the viewport over that background, but not the background itself. So that's one thing that we should probably remove from here and make like a trigger when anything is written on that range of address. This is still rudimentary for me at least, but I think that will solve our problem and still makes the code work. So oh, thank you Knox Harrington. Thank you for the following. Thank you a lot. Welcome to the team. We are trying to build a Game Boy emulator here. In this episode, it's episode number 17. Some juice. And we are almost there. I mean, almost there for seeing game stuff. The Nintendo logo you already saw on the screen. That was very nice. So let's do that. I will do something here. So get tile set. Yeah, so for here, we are assuming our tile set is only the first bytes, first 256 bytes of this record, of this area. But that's not true because we already saw where is that? Emulator docs. Oh, I think I didn't. We have an area of actually this entire area. Let me get back there. I think in this tile set. Tile set. Special address. Okay. Here. So, from this, from this document, from the guys from PyBoy, we have this document, which is very nice document. Wait, do you rasterize? Actually, I will do not. So yeah, that's what I just said then. And what I'm doing, what I saw is that the populate background buffer is our bigger problem. Calculate the viewport is not spending too much time. It's still spending time, but calculating the background buffer is one problem. And I think we can calculate this buffer only when any data from this area is written. So When I write the memory in this area, I calculate back the background data, because the background is just the tile set. Oh no, actually it's this area. Yeah, sorry. Yeah, I need to calculate the when any thing is written between this area, so the tile data and also the tile view, which is the tile map, I need to calculate the background buffer again, because if something changes on the screen, it will require to calculate the buffer again. I think that's it. So I will no, I mean that you make a mini FB tile. Oh yeah, that's another stuff. Yeah, I was thinking on only remove this part, which is, like you said, transform the tile set to mini FB, to rasterize it. But I can do this with the entire matrix, because, and also I can remove this for doing this calculation only when this area is then is specifically this area. Yeah, so but there's two things then. I can first only populate the background when this area is changed. Populate the background. I will still not remove the rasterized part. And then for the mini FB transformation, I only reperform that calculation when something in this area change. Some tile in that area change. Because when a tile is written here, I perform the calculation, I transform that new tile into mini FB tile and record that in one part. That's true. That I can do also. Actually, as you are saying, I think I can remove that first. And yeah. Yeah, so I think I can like let's say like, is rasterize the right term? Yeah, you are right. Rasterize. So I will do exactly what you said. Dan, thank you again. So I will prepare a rasterized tile set in the PPU, which will store only the tile set. Only the tile set, but already rasterize it. And how will you do that? I can just initialize it here, and then I can do something like this. this function does not need to be called. Yeah, you are right. This function does not need to be called every time I do the map from the map. I mean, I populate the buffer, the background buffer, because that is only getting one. Yeah. So this part. Yeah, is a. Yeah, I would do exactly like that. I do something like this. Well, first of all, I need to calculate but there is one thing here. For the time, just yeah, but I need when I will do, I will start calculate. I will start rasterizing. I could not rasterize every time. I don't need to rasterize every time I write in that memory range because I will not have for example, when I'm writing only one byte, it's still not a pixel. Even if I write I need to write 2 bytes to have one line of pixel. So I need to wait at least 2 writes on that. And that should be a consecutive writes. But I think anyway I can calculate. Even if I calculate, if I rasterize the entire tile data. Yeah, let me explain better what I'm thinking here. So yeah, I will change this I will change this because first thing is I will have here in the PPU an rasterized tile set, right? And every time this get tile set function, I don't need to go to the to memory management unit. I can get it from myself if I record this. No, I can't. Yeah. Okay, so get set. Okay, so the tile set has 250. So let's keep that way. I will do this. I will do is something like I will on write byte if address is greater than or equal to 8 or and address is less than less than 0x98. If I'm writing any data between this area, so this area, I need to rasterize it. Okay. And okay, so I need to rasterize it. Okay. Let me so I will change the so now I need to discover which tile I need to change. If one tile is made of 16 bytes. No. 16? Wait. So one tile takes one line takes 2 bytes. It is so yeah, I need 16 bytes for one tile because every line, yeah. So I need to calculate that and get the entire tile and rasterize it again. Only the tile, right? I don't need to rasterize the entire tile set. I can rasterize only the tile when it's writing. It should be writing only in the beginning of the game. I can even rasterize the entire tile set every time, but that will take a lot of time in the beginning. Okay, so I will do. First I will do this. Rasterize the tile being changed. Let's begin. Why am I think when I start streaming, my machine gets slow. Start rasterizing. The entire tile set and later refactor. Rasterize. Okay, so I will start doing the entire. I need to call PPU. Okay, I need to have one function. Okay. So let's do this. Pub function rasterize entire tile set. Mutable self. I will not mutate the memory management, but I will mutate my tiles, my self tile set. So what I will do from, so I will do this from this. So the thing is simple. I will for so how many how many? So it's 8 kilobytes. Eight kilobytes is so I will rasterize the entire I'm thinking here because I will then put this as index for this tile set, and then I will need a map. No, I don't need a map. I can just calculate. Yeah. So yeah, I just will do this. So I will do something like I will do this for so let tile self get tile the first byte is my, yeah, exactly like that, and that's it. So I get one tile, rasterize it, tile equals to self. Yeah, I think I will start changing the name of this. I like it this rasterize tile. Raster tile. It should be raster or rasterize. Rasterize or raster. Raster, yeah, raster tile. So I will raster this tile. And rasterized tile is raster tile. What I need here is, yeah, and the tile. Great, and then I do self rasterized tile set. I rasterized tile. Okay, so what's this? Okay, or yeah, What I return here? Oh, I return. Yeah. So actually, I will need to do. Yeah. Yeah. Now we have this hoster. No, chumot. Okay, that rasterized. I will let the rasterize it. Is this correct? Hostered? Hostered. I don't think that is the same meaning. No, yeah. So it's rasterized. How or rasterized? No, it's rasterized. Let's rasterize it. I'm not English native speaker, so anyone there, if you wanna help me, I think rasterized tile is okay. Then then I will be doing other stuff. What else I'll be doing? Yeah, so now I have a function to rasterize the entire tile set. I can call this from here. So I can do PPU. Oh, I'm not having PPU here. So I can do this. I can move this. Oh, anyway. Oh, wait. Oh, now I have a problem. I don't have PPU here when I'm writing a byte. So if I don't have the PPU, how can I do that? I will do pa-pa-pam. Who is calling me? Well, it be called by CPU and also by PPU. If I move this, well, what I can do is hold the reference for the PPU, when it starts, yeah. Then I can do this. I need to specify a lifetime here. PPU. Yeah. Now I need to I think this should be like yeah. And then here we also need is so this is the lifetime. So in Rust we need when we have a reference inside a struct we need to specify a lifetime. This is like this is the lifetime. So I'm saying that this how much how long this reference will stay in the scope. It's something some kind of that. It's to be able to compile, see if that reference is still valid or not. So here I need to do the same. And here I will need to receive the PU, and here I will specify that this is also yeah. But here I have something to fix. Oh, sorry. CPU is yeah, but this should have yeah. Now it's correct. Yeah. So let me explain this. I'm saying that the lifetime of this parameter is the same lifetime of this. What is specified here is the same lifetime here. So I make the compile knows that what else I put here, what else reference I put here, need to be longer, or this should this need to be longer than what is inside. Otherwise, I will pointing to something that does not exist. So that's why I use this. Rust uses this lifetime to be safe during the compile time, that these will still be available. So now we have a reference for the PPU inside. Then we can do this. Self PPU. Rasterize. And I will pass as parameter self, because I am inside the memory management unit. Now, every time I write something here, this tile set will be populated with the real tile. So, just with this, I don't need this anymore. I can get the tile set. Yeah. Instead of getting the tile set from our and why it's only I think this could be I still need to check this, but just a minute. One moment, please. I will be back soon. I'll be back in 1 second. Yeah, guys. Unfortunately, I think I will. Yeah, I will stop for today. I think I need to take care of my dollar. And anyway, we'll get this. We will get this done for tomorrow. If I have time tomorrow morning, I will get back on tomorrow morning online. Yeah, I will stop for today. Thank you for watching and see you tomorrow. Thank you. And sorry for stopping early today. Thank you a lot.